Just 4.2 light-years from Earth, beyond the frozen edge of our solar system, a small world circles the nearest star to our own. Its name is Proxima B. In the scale of the universe, it is practically our cosmic neighbor. And ever since astronomers discovered it orbiting the red dwarf star Proxima Centauri, this distant planet has become one of the most fascinating worlds ever found. Because hidden beneath its crimson skies may lie the answer to one of humanity's oldest questions: are we alone? At first glance, Proxima B seems strangely familiar. It is similar in size to Earth and orbits within its star's habitable zone, the region where temperatures may allow liquid water to exist. That single possibility transformed Proxima B into a world of enormous scientific interest. Because wherever liquid water exists on Earth, life follows. But Proxima B is not Earth. Not even close. The planet circles astonishingly close to its star, completing an entire orbit in only 11 Earth days. And unlike our calm yellow sun, Proxima Centauri is a volatile red dwarf, smaller, dimmer, and far more violent. Under its reddish light, Proxima B may experience conditions unlike anything in our solar system. One of the planet's most remarkable features is something called tidal locking. This means one side of the planet permanently faces the star while the opposite side remains trapped in eternal darkness. On Earth, day and night constantly rotate across the globe. On Proxima B, they may never move at all. Imagine standing on the daylight side. The red sun hangs motionless in the sky, blazing endlessly above the horizon. Heat and radiation pour constantly onto the surface without relief. Now imagine the opposite hemisphere. A frozen world locked in perpetual night. No sunrise. No sunset. Only darkness stretching endlessly beneath a sky filled with unmoving stars. Between these extremes lies a narrow twilight region known as the Terminator Zone, the boundary where eternal day meets eternal night. Scientists believe this may be the planet's best chance for habitability. Temperatures there could remain moderate enough for liquid water to survive. If life exists on Proxima B, it may exist within this endless band of twilight. But survival would not come easily. The temperature difference between the scorching day side and frozen night side could create colossal atmospheric winds sweeping across the planet at incredible speeds. Storm systems unlike anything on Earth may dominate the skies. Entire oceans could freeze on one side while massive cloud formations boil endlessly on the other. Yet despite these harsh conditions, Proxima B remains one of the most promising worlds in the search for extraterrestrial life. Because life on Earth has repeatedly shown something extraordinary. It adapts. Organisms survive in boiling volcanic vents deep beneath oceans. Microbes endure acidic lakes and radioactive environments. Life exists frozen beneath Antarctic ice and buried kilometers underground. Again and again, biology pushes beyond what scientists once believed possible. If life found a way on Earth under extreme conditions, perhaps nature could do the same beneath the red skies of Proxima B. But the planet faces another enormous threat. Its star. Proxima Centauri is highly active, unleashing violent stellar flares capable of flooding nearby planets with dangerous radiation. These eruptions can be far more powerful than anything produced by our Sun. And because Proxima B orbits so close to its star, it may be struck repeatedly by intense bursts of charged particles. Over time, those flares could strip away the planet's atmosphere entirely. Without atmospheric protection, the surface would become exposed to lethal radiation and the harsh vacuum of space. Mars may provide a warning of what happens when a world loses its protective shield. Yet scientists have not given up hope. If Proxima B possesses a strong magnetic field like Earth's, it could deflect much of this radiation and preserve an atmosphere capable of supporting liquid water. Deep beneath the surface, underground oceans might survive protected from stellar bombardment. And somewhere beneath endless twilight, life may be waiting. As scientists continued studying Proxima B, strange possibilities began to emerge. Not proof of alien civilizations. Not evidence of artificial structures. But mysteries. Subtle observations linked to the planet sparked discussions about unusual emissions and unexplained signals associated with its dark hemisphere. Astronomy is an incredibly difficult science. Researchers study worlds so distant that even the most powerful telescopes detect them only as faint points of light. Tiny fluctuations in brightness or radiation can sometimes produce strange and unexpected results. Most anomalies eventually find natural explanations. But until they do, curiosity grows. And imagination follows. Some scientists believe unusual signals near Proxima B could result from powerful interactions between radiation, magnetic fields, and atmospheric particles. Auroras larger than entire continents may ripple across the planet's skies. Massive electrical storms could release strange bursts of energy into space. Volcanic activity or charged particle collisions may create electromagnetic signatures unlike anything observed on Earth. The universe is capable of producing phenomena far stranger than early theories predict. History has proven this repeatedly. When astronomers first discovered pulsars, their signals appeared so precise and regular that some jokingly labeled them possible alien transmissions. Fast radio bursts puzzled scientists for years before researchers began uncovering possible natural origins. Again and again, nature reveals mechanisms more extraordinary than fiction. Perhaps Proxima B is another example. Or perhaps it is something even stranger. Today, powerful instruments such as the James Webb Space Telescope are beginning to analyze atmospheres on distant exoplanets in unprecedented detail. Scientists search for chemical signatures, oxygen, methane, carbon dioxide, water vapor, clues that may reveal whether a planet could support life. Future observatories may eventually map weather systems on nearby worlds. Detect cloud layers. Measure atmospheric chemistry. Even identify seasonal changes across alien landscapes. For the first time in human history, we are approaching the ability to study distant planets not as abstract data, but as real places. Worlds with climates. Oceans. Storms. Possibly even ecosystems. And among all those distant planets, Proxima B remains uniquely compelling. Because it is close. Close enough that future generations may someday attempt direct exploration. Already, scientists have proposed concepts for ultra-fast spacecraft driven by powerful laser systems capable of reaching nearby stars within a human lifetime. Such missions remain experimental, but they represent something remarkable. Humanity is beginning to think seriously about traveling to another star system. And Proxima B may become our first destination. Imagine what explorers might find there. A frozen wasteland beneath eternal darkness. Towering storms beneath red clouds. Subsurface oceans hidden beneath thick layers of ice. Or perhaps something no one expects. Because every time humanity studies the universe more deeply, reality becomes stranger. The search for life beyond Earth has never been only about discovering aliens. It is about understanding our place in the cosmos. Are worlds like Earth rare? Or does life emerge wherever conditions allow? Could biology adapt beneath perpetual twilight on a planet battered by radiation? Could alien ecosystems exist in forms unlike anything evolution produced here? Or could the universe contain possibilities we have not even imagined yet? Somewhere just 4.2 light-years away, beneath the dim red glow of Proxima Centauri, a small world continues its endless orbit through light and darkness. silent, distant, waiting. And perhaps one day, humanity will finally look upon its surface and discover whether the universe has been alive all along.